We're going to start this lesson by reviewing what you learned about circles because we're actually going to be doing systems with circles in this lesson. So whatever you learned last year, if you're watching this in 2021, one thing you should have learned, a circle whose center is at HK, and this should be in a normal spot in your notes. Basically, and the radius is given by r, this is how we write a circle equation. So for now, I'm just going to leave it there. We're going to look at examples, and then hopefully it'll become kind of clear. So if I know the center, the coordinates of the center of a circle, and how big the radius is, that distance from the center to the outside, I can write the equation of the circle like this. So it says, which of the following would have circles would have a center of -3, 6, and a radius of 3? So basically, when I see a -3, because I'm using subtraction here, I'm going to write +3. And then we have squared for the circle. So if I have a +6, I'm going to write y -6 squared. So far it has to be either choice 2 or choice 4. Nope, and not even choice 4. Pretty sure it's choice 2, but let's just look at the radius side of things because this one has the wrong sign right here. So then we want the radius squared over here. So if the radius is 3, 3 squared is 9, and I put that over there. So the correct answer is number 2. Just quickly making a connection, you know how when we go left, such as in -3, we write +3. It's that same idea of your transformations here, the opposite. Now what's kind of weird here is this equation is not solved for y, and actually we can't really solve for y easily because of this y squared. So the number is with the y, kind of like a factor, not usually where it is, so we actually do the opposite for the y too. So if it's a +6 for the center, I have a -6 here. So let's look at the next one. I can see that structure of the circle equation. That tells me we're supposed to find the center and the radius. The center is +2, +7, because we're going to change these signs. And then the radius, this is r squared. So if we take the square root of 100, the radius is 10. I would suggest trying a couple little things come up like in letter C, but just see what you can do and then come back. So the center here is +5, -8. And the radius is the square root of 4, which is 2. Here, when nothing is added or subtracted, we could just assume the center is 0, 0. The radius is the square root of 121, which is 11. Moving down the page a little bit, we have 6 more, and at this point you should definitely try them. Just do them quickly. Center, -1, -2. Radius is the square root of 1, which is 1. Center here is 0 for x, +3 for y, and the radius is the square root of 49, which is 7. Center, -6, +5. The radius here is the square root of 18. This is the first one where I don't have a perfect square. That's square root of 9, square root of 2, which is 3 square roots of 2. Now here it says, if the radius is not an integer, express it in simplest radical form and round it to the nearest tenth. So this is our simplest radical form. If I was going to type either this in my calculator or the original square root of 18, that would give me 4.2 to the nearest tenth. So my next one, the center is 0, 0, and the radius is 8. The next one, my center is 4, 2. And the radius is the square root of 20, which simplifies into 4 times 5, so 2 radical 5, square root of 4, square root of 5. And if I type that in my calculator, that's going to give me 4.8. The last one also has a center of 0, 0. Radical 57 does not simplify at all, so I'm just going to write it also to the nearest tenth as 7.5. So oftentimes we want things in simplest radical form, but the next thing we're going to look at is graphing these circles. So graphing is a lot easier when we have decimals versus some sort of radical that I'm not sure exactly what it equals. Down here it says we're going to graph circles D, G, and H on the grid. So let's start with D. So D has a center of -1, -2. I'm not sure how much you remember about circles, but the center is not a point on the circle, so it doesn't really count, but we use it as a guideline. This one just has a radius of 1. So I'm going to go out around the circle. Basically, if I go, and this is going to be ugly with a stylus, but I basically go 1 in each direction. and then I do the best I can to draw a circle. As I said, this is gonna be ugly. So there's my circle, okay? Imagine it's a good circle. I can't get it much better on the iPad. So looking at the next one, we are graphing circle G. This one has a center at 0, 0. So G, and then we have a radius of 8. So this grid is actually 8 out in each direction from the origin. So when I draw, I'm gonna do this one in blue actually, so we can tell which is which. It's a little easier to draw with a stylus just because it's a bigger circle. So I'm just gonna label them. This is circle G. This is circle D. And our last one, I'll do in green, is H. So H has a center of 4, 2. Do my centers in red, but then I'll do the circle in green. Now this one, we need to go out 4.8. It's gonna go a little bit off the grid in this direction. So it's about there, a little bit past the y-axis because we have to go over 4.8, and then up about here and down to 4.8 to about there. So we'll sketch this one in, and that's circle H. So when we start doing systems with these, we're actually going to talk about doing the systems graphically as well. So graphing the circles is just a piece of that.